Indian automobile manufacturers in particular are looking to embrace the advanced technologies is a question on many people's mind. So at this time, can I please ask Head CAE CFD Methods and Development, Mahindra and Mahindra Limited, Akella Sarma, to please share his take.
Good afternoon. First of all, I'm delighted to be part of this STC, ETAuto STC 18, and thanks for inviting Mahindra into this. I don't want to give any introduction, big introduction of Mahindra, because everybody is aware of Mahindra and Mahindra. The topic which I selected based on the kind of the titles, Testing, Simulation and Testing Congress, is something like a simulation driven product development. I am sure it will be interesting to everyone. I will just take you to a little bit deep dive into the engineering aspects, how you actually apply the available tools and technologies to leverage the kind of the benefits based on the challenges what we are going to face in next 2-3 years. Yeah, the contents are something like, I just want to move around, and the current challenges, and we have emission and CAFE norms coming up, and we also have options to overcome, how do you really overcome these challenges, and what kind of emphasis need to be given to engineering. The weight management is a big item which plays very important role in containing the CO2 emissions. And if we need to really focus on the weight management early, what kind of the changes you need to adapt to the product development process. So I just want to touch upon some of those things. And once you have a process, but how do you really effectively use the available tools and technologies for you have to balance the attributes, the performance attributes, and as well as the weight. And the simulation technologies concept to detail. So most of the OEMs are actually spending on the design CAE loops, many loops. I am sure everybody is actually spending a lot of time, and we have been using all the tools. But are we using enough? Are we using effectively? What tool should be used at what time of the product development process? I just want to touch upon those things. And then the last one, but not the least, what is the impact? Yeah, you do a lot of simulations, but at the end of the day, the management will ask, hey, what, we are doing a lot of testing also. So what are we going to, how are we going to reduce, and what are you going to get benefit from the simulation? There is a lot of investment into the simulation. So yeah, these are the things, I don't want to spend most of the time, because we got a lot of insights from the morning panel discussion and as well as a lot of talks. So we have very strict norms with respect to reduction of NOx and PM, particulate matter, and for diesel and as well as gasoline. You can achieve through some of these through technologies related to DOC or DPF or whatever after treatment kind of processes. And one important thing which is coming up is the GST framework, which is for the passenger car segment, where if you do not really concentrate on reducing CO2, you will be paying more taxes. So what are the options to overcome these challenges? I would rather say one is the weight reduction. This is an engineering aspect which I want to concentrate in this particular talk. We have optimized designs and alternate materials, the engine improvements you can do, fuel upgrade. Now all these are all simultaneously you need to do, but I am going to focus on only the weight reduction, optimized designs, processes and tools and technologies. Just want to give you some global trend. I just picked something from the literature, available literature. There are two things. One is for example, if you want to improve the performance with respect to torsional stiffness, and you can add weight, and then a lot of people add weight to get the best torsional stiffness and bending stiffness. But you are actually doing the other way around, because the lightweight index is more important with respect to the kind of challenges what we have seen. If you really see this Hyundai i40 and BMW, their torsional stiffness is about 35 and 27, it is all that range, and their lightweight index is very, very low. I know you are aware of this, but how do we really improve the performance with respect to the torsional stiffness, and if you need to do this, what is that you need to do, where you need to do all this? It is not towards the end of the program where you are releasing the drawings and you are trying to do optimization towards the end of the program. So, just getting into the little bit of deep dive into this, how do we really do this? I have just picked some of these things, relevant things to increase the performance of the vehicle torsional stiffness, and also look at the kind of weight reduction. If you adopt multi-ring body structure, which is the very well known and everybody is applying, that is one thing which will improve the torsional stiffness. And you need to really focus on joint stiffness improvements. You have to really see where exactly the joineries are important and how they are contributing to the stiffness. So, people can do a lot of sensitivity study, which one is contributing more. So, what kind of treatment need to be done for that joinery. Then the most important thing is the section optimization. See, if you really take the BIW section optimization, are we doing really enough things early in the program? So, that is what is my important thing, because generally the CAE engineer will get CAD some point of time, after 3-4 months or some kind of 1 year of work in the concept, and then he will be asked to do some kind of a 3 loops CAE, and then he will recommend some changes, and then by that time he comes to the 3rd loop, the vehicle architecture is locked, and we have finalized a lot of manufacturing processes, supplier on board. So, you will not be able to accommodate any of these kind of changes what you recommend if you do optimization towards the later part of the program. So, for that you need to start early, and one way you increase this stiffness by adding reinforcements and things like that, but you also need to have a material strategy to balance this. Are we using enough of high strength steel? And most important thing is, if you really look at some of the next generation vehicles of Santa Fe and other I40, you have 70 to 100 meters of structural adhesives. So, where are we with respect to? So, I just want you to give this information. These are all things actually linked to the kind of how do you reduce the mass and how do you really increase the torsional stiffness, which will lead to the comfort of the vehicle. So, what does it need? So, there is a need to really do early. So, what is the current process? We are actually doing a concept phase some time of the program. Then we have a detailed design phase where you have a design loops and CAE, the final CAD and doing optimization. Somewhere when you are actually reaching, then you will realize that, oh, you are not meeting the weight target. So, then people start doing the weight optimization, and you do not have the flexibility with respect to manufacturing processes, the flexibility with respect to the packaging, architecture is locked. So, you will not be able to implement whatever you suggest based on the optimization. what I suggest in this particular thing is, you need to extend the concept phase a little bit, and detailed design is something like a confirmatory kind of stuff. So, you do optimization early in the program. For example, important thing is, even before, the designer has to do lot of CAE. He is using the old way of using the Excel sheets to get to the some kind of calculations is over. Now people are actually getting into the mobile apps. For every system you actually can create a kind of a app and see these are the inputs and what is my parameter which is influencing the performance of the system. So that the run can be done in the server, but he can operate through a mobile app and then run the particular calculation. It's a 0D or a 1D or a 2D kind of application. So are we using enough? This is exactly what I want to really tell you. The designer level, we need to, the CAE guys need to really facilitate this kind of front end, the front loading kind of simulations to the designer. Today we actually say that CAE engineer is he knows the finite element and everything. So he doesn't want to really give it to the kind of designer community. But I think you have to democratize the tools and technologies. You have to apply some of the tools early in the program. Whoever applies it, it doesn't matter, because you always need to have actually a better design before a detailed CAE analysis, so that you converge faster. You don't have to do many loops if your initial design is perfect. I am sure most of the tool vendors, like software vendors, are concentrating on this particular area and then providing a lot of design calculations or a designer level CAE tools. So are we using effectively in our program? That is what I wanted to really question this. Once you get that, the concept itself, you need to really do the section optimization. So that is where your inputs will be taken into the vehicle architecture. You can change things and you can actually define what kind of manufacturing process you need, and you can recommend that early in the program. So that is where the term called MDO, multidisciplinary optimization, plays a very important role, where you have all the performance targets, you take it and then you run a kind of MDO, and then you can actually get into a kind of gauge, grade and geometry kind of recommendations. Once you do that, see, this is exactly the thing, you can do a final optimization towards the end of it if there is a need to do it, but that may be a little bit of a thickness kind of optimization. So that can be accommodated. But the most important thing which I want to tell you is section optimization and the more methods development, 1D, 2D, and then you actually apply those things before you mature the CAD. So coming to the latest technologies, yes, we have, every OEM has got every tool, every whether it is a Dassault or you have Altair or MSC and Dyna, everybody uses all the tools, but my only request is to apply these tools at appropriate time. For example, if you want to use a multi-physics console, where are we applying? Towards the end, or you want to do it at the beginning? Or can you create something with a kind of 1D, 2D kind of simulations inside based on your system configuration? So how you work with this designer level CAE, you have to really make it available to the designer, so that you get a better design to evaluate in terms of a detailed analysis. Yeah. So this is exactly the thing which we actually adopted in Mahindra, the concept evolution, the design calculators. We create a lot of 2D apps and 1D apps, and all these are all applicable to the every system has got these kind of apps. So the designer has got access to all these apps, and then he will just put he'll he'll just enter the template, what all required, and then he'll get an answer. The whole run, whether it is a 1D or a 2D, will happen in the server. So he doesn't need to understand finite element or what is the mesh quality and things like that. And you can also do it, these are the kind of things, if you really, somebody is designing a stabilizer bar, what kind of inputs you need to give, and you have to really understand that engineering content, what is there in his mind, how he designs, and then put it in a kind of calculator and make it available to the entire designer community. And the old Excel sheets, you should come out of it, and then you have to really get into these kind of apps, because the storage of data, what exactly calculations are there. See, it is a kind of the information is pulled into one particular kind of a server, there you actually make it available to the entire designer community. So, coming to the first part of it, the concept design, 1D, 2D, and you have some kind of designer level CAE. Now, next it comes to the CAE as for a detailed design. So, what he needs to do? He needs to do a lot of things with respect to the balancing all these attributes. For example, if you are preparing your car for a Euro NCAP and you have a NVH targets better than the predecessor model, and you have a vehicle dynamics related ride and handling, or you want to have durability thing. So, all these things simultaneously we need to really take up. It is not the, see, earlier we used to do individual crash, used to do a crash optimization, and then he will come up with some kind of thickness reduction or some recommendations. Then the durability guy will do his own optimization, but you will not be able to really, the designer will not be able to understand this, and then what is best for everything. So, that is the designer is getting confused every time. So, you need to really do that, what is meeting with respect to all this, and then the weight target that needs to be given to the designer. So, that is how the CAE team has to pull a lot of these things and push some of this 1D, 2D level analysis to the designer. Coming to the concept optimization, how it can be done. I mentioned about some of these section optimization. There are a lot of tools and technologies available. Take from the volume model what you get from the styling, and you start your design optimization, vehicle architecture level, you do a topology, and then get to the sections, master section model, and then you do a design exploration with respect to parametric FE model. These kind of tools are available today in the market. So, you can actually fiddle the with the parametric FE model, and then you populate the kind of load path with respect to the sections what you want, and then you populate with mass, where exactly the load based on the load path direction. Then you get an optimized section model, then you take it to a kind of an MDO with respect to the gauge and grade. So, this is the process which I was just mentioning. This need to be pulled early in the system, early in the product development process, so that you actually contribute to the kind of product. This is the kind of topology I was just mentioning. You take a 3D volume model, get to the finite element model, and then you can actually get to the load cases, whatever load cases you have, crash and durability, and then get to the effective load paths, and then you populate the kind of based on the load path, you populate with mass. And the beam models optimization is a very old strategy, but still effective. I just want to mention this is also playing a role in terms of at the concept level, and you can actually make use of this. The parametric FE model, what I mentioned, this is the source I have taken it from SFE. The concept optimization, you take the topology, based on the topology you actually do your kind of mass distribution, then you do a design of experiments, and get to the response surface methodology and then optimize structure. So, this is exactly the thing which is needed in terms of weight reduction or weight, correct weight management. I would not reduction, because you are actually doing at the early stage of the program. So, you want to really focus on this to give what kind of appropriate mass to be there in the vehicle at early stage. So, you do not have to do later part of the program lot of these things which you debate with your vehicle architecture team. Can you accommodate this, can you accommodate this? I do not think that you need to really do this very early in the program. And then important thing is, if you are actually having a common platform and more upper bodies, so you need to really agile enough to pull the platform validation or in terms of simulation first. So, make the platform robust for these identified kind of variants. And then how do you do it when you do not have a upper body? So, you need to use the technology with respect to morphing what is available today, and then you start validating the kind of platform. It is the detailed things are available. This is like a master grid library, and you have a predecessor output input model, then you map it, and then you get you can actually fiddle with what variant you want, the target variant, you can actually morph it. And most important thing, when you do all these things, at the end of it, what is the impact that you are actually creating to the top management or in any OEM. So, lab simulation and test. Morning also we have seen some of the controlled environment kind of tests in the lab. So, when it comes to correlation, the strategy is the field need to be the RWP, real world usage profiles, need to be bring it to the track. The track whatever they are doing, that needs to be, you need to bring it to the kind of lab, and that needs to be correlated there. Once it is correlated in the lab, then CAE has to really the lab to laptop. So, you need to really pull that to the laptop and then you start. But how do you do it? This is an important slide where we spent almost 2 years. Today we see benefits. The CAE and test load case alignment is a big issue. Test guy will do with respect to his own way of doing, CAE guy will do with a little bit of different loading conditions, different boundary conditions. So, unless you make them sit together and then say I want only one document which is loads and boundary conditions, BOM and acceptance criteria, all these three, you release a document which is signed off by every test engineer or a CAE engineer. So, there are both the guys need to sign, and then you start the CAE guy need to really track the correlation on that particular load case. So, we have been doing most of the things like this, and then once it is inputs are correlated, this is actually the input correlation. Once it is input correlated, then you can actually get into the trends matching, like the designer will expect from you that if I change this, something is going to happen, right? That something is going to happen is exactly as per CAE, or do I need to go for a test? So, this is the confidence that you need to bring in. I know that moving from the load case alignment to the trends matching kind of correlation, you do not need a big set of tools, but it is only a directional kind of input, and I am sure everybody is there. But from trends matching to the absolute value matching, you need a lot of capability building with respect to tools and technologies, the modeling details, that is where the CAE roadmap will come. The roadmap will come from CAE that these are the things which I do not have today. I am at actually a C1 level or a C2 level, but I want to move this load case to the C3 level. So, why should I move to the C3 level? This is the kind of confidence that you give to the designer, and then if you have more data points on C3 level correlation, that means one load case is having 3 or 4 times absolute value matching correlation, then you should ask why are you doing this test. So, this is the impact which a CI engineer or a CI department needs to have on the entire product development. So, otherwise doing more simulations and generating more data is not important, is actually need to be, you have to start with how many tests are available, how many tests can be mapped to the CAE, then you start working on load case alignment, then you start trends matching kind of correlation where where you are there or not, then you move to the next level, and then when you have a sufficient data points, that is it, you have to go and tell at least to the lab, not on the, this is for the design perspective, you should you should not do these tests, but for the material conformations or manufacturing processes you cannot avoid these tests, some of these tests you cannot avoid. So, but for the design perspective you can actually propose this. So, in summary, I am just coming to the last slide, I can open up for discussions. Focus on concept design through topology optimization and B models, parametric FE models which is there in the kind of the tools are there already, and morphing techniques. Enable designer with automated CAE processes, otherwise you will get into a lot of loops of CAE and then it's a waste of time. Then you have to get into the performance attributes, how do you achieve a lightweight and lightweight index, you have to define your lightweight index. I think I have shown you the how it is defined, it is something like a mass of the vehicle by the kind of the width and track, you have for a given kind of a length of the vehicle, what is the lightweight index you can define, and if you want to have a right torsional stiffness. So, apply MDO, multidisciplinary optimization, in the concept product development process, which is very very important, because your output of MDO will be implemented in the architecture, so that you move forward with a very very matured CAD model that can be, you can actually do a confirmatory runs in CAE later part of the time, and then release the whether it is a part or the vehicle level drawings. So, that is all I have. Thank you, thanks for ETAuto for giving me this opportunity.